Step 2. We create a schema for them. Behind every enduring monument, there's a robust plan. Do you agree? To have our work be principled from the very beginning, we also need the plan to connect the components of our project, facts, and dimensions in the right way, based on which we can perform the next tasks with better insight. So we gotta connect these data smartly in the second step. What does that mean? If you have followed the training from the beginning, you'll remember that we said in the last segment that we have the same tables in the OLAP SSAS world. It's just that we're assigning concepts to these tables and categorizing them into facts and dimensions. After doing this, facts and dimensions need to somehow communicate with each other. There are several well-known methods to make connections between them, such as the star method, snowflake, and so on. The names that are assigned to these schemas are based on the way they connect facts and dimensions. For instance, what does the star schema do? It means that the connection between the facts and dimensions resembles a star. It means it considers a fact logically placed in the center with several dimensions connected to it, which makes them communicate with one another. Now deciding which dimensions should connect to which facts depends on the project objective. To better understand this, let me make an example from the real world. Let's go to the Power BI environment and see a sample together. We'll then get back to the slide and carry on with our work. This is a sample we're going to work on at the end of phase 2 in the 6th step, the interface. For now, just look here to better understand what we're talking about. What the customer eventually wants from us is something like this. He wants to see an output of total sales after selecting his desired year, half season, season, and month. I'll make one selection, for example, and you see that the output changes based on my selection. Now, these 4 items are my dimensions, which means it extracts the data from dimensions and displays them here. And this output that displays the final calculations based on the selected values would be my fact. This is what the customer sees, but it's all complicated back there, and some operations must have run. I must have prepared them beforehand. I must have recognized the dimensions correctly and created the hierarchies. Now, a hierarchy of years, half season, season, and month have been created here. I must have specified how these dimensions are related to the fact and how this connection is made. These are the things that we design in the 2nd step and are based on some standards. These are the things that introduce you as an SSAS expert, or else this layer would be the easiest part of your work once everything is already prepared. You just gotta drop and drag everything you want to display to the customer as the output from here. This is why I've defined the 6 steps to the point of delivering the project to the customer for you, and each step requires some work to be done so that we can provide the customer with the desired output. Now, when we talk about a scheme in this step, we mean these connections we just discussed. Things such as what dimensions are, what facts are, how they're connected, how to make the connection between them, etc. The output of this step would be a series of connections between dimensions and facts, which determines the base and foundation of our project until the end. Now, to better understand it, let's go back to the slides and see the output of this step. Suppose you've gotten a project in the field of online shops, in which the customer tells you he wants to have a dashboard that displays specific information such as total sales after selecting a specific date, product, and store. Of course, this is an extremely simple example just to better understand the concept. Well, here we want to know what the facts and dimensions that we need are. It means that you gotta do the exact same thing in the second step. Consider the customer's request once again. He wants to see total sales after selecting a specific date, product, and store. As an SSAS expert, I gotta analyze his request in my head quickly. It doesn't require you to do anything special. Just check 2 items. See which parts of his request are conditions and which involve calculations. This is a trick I've learned based on experience, so make sure to pay close attention. He has given me 3 conditions and 1 piece of work involving calculations. What were the conditions? He says I want something to happen when I enter a specific date, store, and product. So these 3 conditions will be my dimensions. I gotta have 3 dimensions here. What did he say afterward? He said that he wanted to see total sales after entering these 3. Here, he's talking about computation. This will be one of the fields in my fact table. So here, I know that these total sales will be one of the fields of my fact table. As he goes on talking, I discover which other dimensions and facts he needs. Just as easy as that. Okay. So, let's move on. So, we're gonna make a decision based on 3 dimensions. This means we gotta consider 3 dimensions. Date, product, and store. We can consider another dimension for the customer in case he wants to engage in decisions making. Let's carry on with the 3 dimensions for now. So we need 3 dimensions, which you can see here. The primary key is date key for the date dimensions, product key for the product, and store key for the store. Remember the output you just saw in the Power BI environment. These will be the part where the customer will pick their values. Let's not forget that dimensions were the same as tables to which we merely assigned concepts here in the SSAS world. So we gotta say that we need 3 tables. For example, the date table, which includes all the dates. For instance, the exact data must be clear and all the times to the point of hours and minutes must be specified too. We would even make decisions up to the layer of minutes if the project needs us to. We'll learn this later, which is called the hierarchy, and it should be implemented on that specific dimension if need be. Sometimes we see that we lack a specific table we need for our work. This is where we need to make it ourselves. For example, the date table is not as detailed as the customer needs it to be based on the data he's given us. The good news is that these types of tables are common among most projects, and you can find and download them on the internet and customize them based on your own project. Another table is the table containing all the products of the business and has these data and are stored in the product table, for instance. And another table will include the list of stores, suppose they're in the store table. So what happened? The three dimensions based on which the customer wants to make decisions will be our dimensions. So these three are our dimension tables. Now, what's the other table we need? Let's go to the next slide. We need a table containing the list of the transactions in the business. Here, the type of the table is different, since we're talking about detailed transactions. The concept of dimensions is no more involved. Here we need another concept that can give us an output based on our conditions, dimensions. Pay close attention. This is a computational table. We're talking about the detailed transactions of the business. Remember the customer's request again. He said he wanted to see total sales after applying 3 conditions. So the nature of the customer's need in this section is computational. In this example, do you agree that one of the transactions of this business is that each product sold on a specific date and in a specific store is available in a table? So we need at least 3 fields in the table containing the list of the transactions. The product field, the field that specifies which product has been sold. The date field specifies on which date the sales has taken place. The store field, which specified where the sales have taken place. And other fields that the table must have based on project requirements. The additional fields that the table needs would be the computational fields that must be available based on our needs. And sometimes we gotta design them ourselves. For example, suppose the customer has asked to total sales, so total sales will be another field of the table. This will be the computational field in our table, which is called measure, and we'll learn about it later. This table will be our fact table. You see here that the table contains all 3 necessary fields, and some other computational fields inside it. Now, what are these 3 fields for? If you remember, we had them in the dimension table too, right? But they were the primary keys there. Now all the 3 primary keys in the dimensions have been repeated here, but as foreign keys. Why is that? Because we should eventually make connections between dimensions and facts. How are the tables connected? Through the main and foreign keys. Is it okay? If I were to explain the fact table further, I could compare it to the business accounting book. The fact table is in fact similar to the business's accounting book, containing the list of the business's sales. And consider the dimensions as the dimensions the customer has in his mind, and based on which he wants to extract some outputs from the heart of this table. I'll explain the same relationship existing in an accounting book between the facts and dimensions when we start our practical work, so you can completely understand it. In the last two slides, we learned what dimensions and facts are. We figured that there must be 3 dimensions and 1 fact in this business. Now we gotta design a scheme based on the dimensions and the fact that we have. Before that, we gotta specify which schema we want to design the map based on. Our desired schema in this section is the star. When we want to design a map based on the star schema, we say that we got a fact table and 3 dimensions tables. Our fact table is placed at the center, and the 3-dimension tables are placed around it and connected to it in the form of a star. Now we've put the customer table here too. Of course, when we say that the fact table is in the center and the dimension tables are placed around it, we mean it in a logical way, and it's not necessarily physically the same way. That's just what we say to better understand the concept of the work. You know that the connection between tables is made through the main and foreign keys. In this same example, the primary keys are in the 3 dimensions tables. And the same fields are repeated in our fact table, using the product ID, date ID, store ID, and customer ID, but this time as foreign keys. Look here, all the 4 fields defined in dimensions as the primary key are considered as the foreign key in the fact table. Now when the business owner comes and selects a specific date, product, and store, it connects to the 3-dimension tables and takes these 3 values from there. It means it takes their ID from those tables. Then it connects to the fact table and searches for these 3 values together. And the computational field in the table has its job cut out for it. It calculates the total sales for these 3 conditions together, performs the search in the fact table, and gives us the result as the final output. And we take the final output and display it to the end user in the dashboard. This is why the fact tables are also called computational fields. You see, it's utterly similar to the accounting book. So we figure that in a star schema, the dimensions are directly connected to the facts. This stage is generally called the schema and must be done in all SSAS projects. And you gotta be familiar with popular schemas and how to work with them too. For instance, the star we just referred to earlier is called the star schema. Of course, I gotta say that this schema is one of the most popular and widely used schemas, and we're gonna work a lot with it during this course. I hope I've managed to clarify why I insist that the 6 steps must be performed fully and in the right order. This way, we make sure that we're taking the next step correctly. See you in the next step, my friend.